All right, so there's going to be about 4 problems over molar ratios on your exam. So I have 4 problems on your molar ratio practice. Ooh, okay. First one, what is the molar ratio of aluminum to oxygen? Aluminum to oxygen. They gave me an equation. Is this equation balanced? I have 4 aluminums on this side. I have 2 times 2, which is 4 aluminums on this side. And then I have 3 times 2, which is 6 oxygens on the reactants. And then I have 2 times 3, which is 6 oxygens on the products. So this equation is balanced. I can find my molar ratios from it. So they're asking me to compare aluminum and oxygen. Aluminum to oxygen. The coefficients in front of each is I have 4 aluminums for every 3 oxygens. So this is my molar ratio. 4 aluminums for every 3 oxygens. So now I just have to find which one matches that. First one, 4 aluminum to 2 oxygen. Well, that doesn't match. 2 aluminum to 1 oxygen. That doesn't match. 3 aluminum, nope. 4 aluminum to 3 oxygen. That matches. So I'm going to say that this is my answer. All right, next one. How many moles of calcium hydroxide, so they want me to compare calcium hydroxide, which is this one, are generated when 4 moles of water, so they want me to compare water, so here, react with excess calcium. So the reason why they say excess calcium is that they're telling you that there's a whole bunch of this stuff, but only 4 moles of water, so this is your limiting reagent. This is the one that's going to limit the reaction. So they want you to compare water to calcium hydroxide. So I have an equation. Check. Is this equation balanced? Let's see. I have calcium on both sides. On this side I have 1 calcium. I have 1 calcium. Then I have hydrogen. On this side I have 2 times 2, which is 4. Hydrogen, I have 2, and then 2 times 1 is 2, so 2 plus 2 is 4. And then I have oxygen, and I have 2 times 1 is 2. And then oxygen on this side, I have 2 times 1 is 2. So this equation is balanced. I can do molar ratios straight from the equation. So I have to compare water, calcium hydroxide. So I have 2 waters for every 1 calcium hydroxide. Notice there's nothing in front of this compound, so I can assume that that is 1. All right, so this goes a step further than the one up top because I can't just like say the ratio and be done. They actually want me to find another ratio with different numbers. So if I promise myself that I'm always going to put water up top and calcium hydroxide at the bottom, ooh, there it is, I can find this ratio. It doesn't really matter which ones I put on top or the bottom as long as I keep it constant with everything on the same side. So for every 2 waters, I have 1 calcium hydroxide. I'm going to set that equal to, the problem says 4 moles of water. So I have 4 moles of water at the top. And they want me to know how many moles of calcium hydroxide. So they want me to find this. To solve this problem, I'm going to cross multiply. So 4 times 1 is 4 is equal to 2 times x is 2x. I need to solve for x, so I'm going to divide both sides by 2. And then x is going to equal 2. So 2 moles of calcium hydroxide is my answer. So now I just have to go here and I'm like, oh, yep, this one matches 2 moles. That's my answer. Alrighty, next one. What is the molar ratio of oxygen and tetraphosphorus dicoxide? So I have to make sure that they gave me an equation, which they did. Then I have to make sure that this is balanced. So I have phosphorus and oxygen on both sides. I have 4 phosphorus on this side, 4 phosphorus on this side. I have 5 times 2 is 10 oxygens, and then 10 oxygens on this side. So this equation is balanced. I can find my molar ratios from it. So they want me to compare oxygen and tetraphosphorus dicoxide. Oxygen and tetraphosphorus dicoxide. Tetra from 4, deca from 10. So these 2 things. I can see that there's a coefficient of 5 in front of oxygen. So for every 5 oxygens, I'm going to have 1, there's no coefficient there, so I'm assuming that's 1, tetraphosphorus dicoxide. So there is a 5-to-1 ratio between oxygen and tetraphosphorus dicoxide. 5-to-1. So, there it is. Look, it's my first one, 5-to-1. Notice that this second one says 1-to-5. If you were to flip these, that would be the right answer. But they asked you oxygen to tetraphosphorus dicoxide. So you have to have oxygen first and then tetraphosphorus dicoxide. Be aware of the order. It changes the ratio. All right, last one in molar ratios. What is the ratio between sodium sulfide and sodium chloride? So Na2S and NaCl. They gave me an equation. Is that equation balanced? Let's see. I have H, I have Cl, I have Na, and I have S. H, Cl, I have Na, and I have S. I have 1 hydrogen on this side. I have 1 chlorine, 2 sodiums, and 1 sulfur. I have 2 hydrogens on this side, 1 chlorine, 1 sodium, and 1 sulfur. So obviously this equation is not balanced. The numbers are not the same per element. So I have to go in and balance it. Let's see. I'm going to do, maybe put a 2 here. Again, this is a trial and error kind of thing. To equal 2, that means I have to put this coefficient in front of here. That also multiplies my Cl, so I have to multiply that by 2, equal 2. But now I see that this one doesn't match, so I'm going to go this side, multiply this one by 2 to equal 2. I have to put a coefficient of 2 there. Then that 2 multiplies my H. So now these match, these match, these match, these match. My equation is balanced. So now I have my coefficients and I can go and compare. So they want me to find the comparison molar ratio between Na2S and NaCl. There is no coefficients in front of Na2S, so I can assume that that is 1 Na2S. 2, for every 1 Na2S, there are 2 NaCl. So my ratio between Na2S and NaCl is 1-to-2. 1-to-2. These ratios can also be expressed as fractions. Don't let that freak you out. It's just 1-to-2. Again, notice that an option was 2-to-1. That is incorrect because the order they asked you to compare is Na2S to NaCl. 1-to-2. 1-to-2. Not 2-to-1. And that is it for molar ratios.